Okay, so this is where we stopped on our study guide a week ago. And so I just want to go through the chapter 1 stuff, just kind of review what we have going on there. So we've already done all of the equations. And of course, you need to, pay attention to these vocabulary words that we have up here. And remember, like, the steps of the scientific method and sort of the differences between laws and principles. And that should all be on your PowerPoint. But I would also look in the book and just kind of read about stuff like that as well. Okay, so here we have the metric scale, and you guys can write this with me. You guys need to be able to do this. So over here on the left, we've got giga, mega, kilo, hecto, deca, base, deci, centi, milli. And then we had micro. I was writing the symbol for it, I guess. Kind of looks like a U with a tail in front. So you need to know that's the symbol for micro. And then nano. Okay, now the numbers. We've got, I'm going to write the big numbers. We've got a billion, million. So you just dropped 3 zeros. Drop 3 zeros again, you got 1,000. Drop 1 0 now, so you've got 100. Drop another 0, 10. Drop another 0, 1. Okay, now you're going to go over to the decimal side. So we've got a tenth, so 0.1. All right, and remember, if you took that decimal out and flipped them around, you would have 10. Okay, so 0.1 is a tenth. Centi is a hundredth. Milli, micro, and nano. Okay, so just like how I had 6 zeros over here with mega, I have 6 zeros over here with micro. Just one of them is before the decimal, so you have to remember that. Okay, so we're gonna do a few conversions now. So you guys remember how we had to do conversions between the metric and metric system, and you have to use that dimensional analysis with like the railroad tracks. So for this one, we have 2,500 millimeters. And if I were you, I would try to pause maybe and try to work it out on your own and see how well you do. So try to pause me right now, and then you guys can go through and see if you do it all right. Okay, so if you're just now coming back on, remember you've got to have whatever units up here, you got to put down in the bottom right. And then instead of going straight to hectometers, I'm going to go to meters. I'm going to go to the base unit. And then you can go through and do the rest of your tracks. So if meters is here, you can go to meters down on the bottom right, and you're going to go to hectometers. So then you have to ask yourself, which one's bigger, a meter or a millimeter? Well, a meter is bigger, so it gets a 1. And there's how many millimeters in a meter? There's 1,000. So if you look back up on your tracks here, see how milli is 0.001? You got to take that number and flip it around and pretend that decimal's not there. Okay, so that's how I got the 1,000. Then go over to the other side where hectometer is, and so you've got hecto and then meter. So the base unit's like meter. So the hectometer's bigger, and you say, okay, how many ones does it take to make 100? Well, it takes 100. All right, so then go through and calculate that. So you've got 2,500 times 1 divided by 1,000 times 1 divided by 100. So So you've got 0.025. Okay. All right, so now try to do this one on your own, this next one here. Got 2,600,000 microliters. Do your tracks. And I'm going to kind of erase this one a little bit. Hopefully you guys had that written down so that I have some room here. All right, so I've got microliters to liters, and then liters to kilometers. Oh, wait. Whoa, what is that? That should be kiloliters. Sorry. Can't go from microliters to kilometers. Okay, so then you got to look back up on your tracks and see which one is bigger. So is it a liter or a microliter? Well, it's a liter. And then you got to look at your micro, flip those numbers, and you've got a million. And then you're going to go and you're going to say, okay, which one's bigger, a kiloliter or a liter? So kiloliter is bigger, it gets a 1. How many liters does it take? It takes 1,000. All right, so now go through, type in on your calculator 2,600,000 divided by a million, and then divided by 1,000, and you get 0.0026. Okay. All right, so that was for the metric system. Now you've got a conversion between English system and metric system. Okay, so this is where I would have to give you some conversion factors. So again, I'm going to erase this from before. So hopefully you had that written down somewhere, because I'm going to write some conversion factors here. And I would give these to you on the test. So let's say 1 mile is 5,280 feet, and 1 inch is 2.54 centimeters. And let's go ahead and say 1 pound is 454 grams. Okay, so let's do this 52 mile one. So we've got 52 miles, and we're going to have to go from miles to feet, because that's the conversion factor that we have. Now, can we go from feet to anything here? I would say we could go from feet to inches. So go from feet to inches. And then we can go from inches to what? To centimeters. And then we can go from centimeters to meters. And then we'll be good. All right, so for every 1 mile, there's 5,280 feet. For every 1 foot, there's 12 inches. For every 1 inch, there's 2.54 centimeters. And for every 1 meter, there's 100 centimeters. Okay, now type it in on your calculator. So you've got 52 times 5,280 times 12 times 2.54 divided by 100, which gave me 83,685. But you got to remember significant figures. So how many significant figures do you have here? You should have said 2. So how many significant figures do we need to have in our answer? We need to have 2. How do we make this into 2 significant figures? I would probably say do 84,000, because I got 83,685. So you could do 84,000, or you could do 8.4 times 10 to the 4th. Either way, it would have worked. Okay? All right, let's do the next one. So the next one, we've got 0.5 pounds, 0.50 pounds specifically. And it wants us to go from pounds to kilograms. So we have pounds to grams given to us. And then we can easily go from grams to kilograms. So for every 1 pound, there's 454 grams. For every 1 kilogram, there's 1,000 grams. So we're going to do 0.5 times 454 divided by 1,000. Now, how many significant figures do we need to have in our answer? We need to have 2. And I got 0.227 when I did it on my calculator. So that's going to round to 0.23 kilograms. Okay, hopefully that all makes sense. All right, then we went to density. And I only did a few because, you could refer back to your homework problems. And I would also like to say to go to if you go to the back of the chapter, so go back of chapter, parallel, exercises, the A section, there's like an A and a B. I've assigned you the B problems on the online homework, but if you look at the parallel exercise A problems, they're just like the B problems. And if you go to the back of your book, they have them all worked out. So that might help you with future problems, But the problem is that people start to just do whatever the other problem did, or they do whatever the guided solution does, and then they don't actually learn how to do it themselves. And so then when you go to take the test, you don't know how to do it. That's my issue with the guided solution. So you really have to know how to do it. And if you don't know how to do it, then you need to, that's when you need to come talk to me or go talk to Dan in the tutoring room, or you just need to practice trying to get them. Okay, so this one says a 2.1 kilogram pile of aluminum cans is melted and then cooled into a solid cube. What's the volume? So I just looked on Google, and aluminum has a density of 2.7 grams per centimeter cubed. And this says that there was 2.1 kilograms of aluminum cans. So that's why I put M for mass. All right, so if you look at your density equation, its density is equal to mass divided by volume. And this wants us to find volume. So if you remember that triangle thing, volume was like this. Okay, so it's on the bottom right. So volume is equal to mass divided by density. All right, now there is an issue. Hopefully you found that this says kilograms and this says grams. So what do you need to do? I would convert the kilograms to grams. Okay, so you've got 1 kilogram is 1,000 grams. So take 2.1 times 1,000, which is going to give you 2,100 grams. And your density was 2.7 grams per centimeter cubed. So I got 777.777 repeating. So how many significant figures do we need? Go with however many significant figures are given in the problem, not whatever's in the chart. Okay, so 2.1 kilograms. So I would do 780 centimeters cubed. That's my answer there. Okay, all right. There was one like this in the book, this number 4. It says, what's the mass of water in a 40-liter aquarium? Okay, so what's the density of water? If you look on your chart, 1 gram per centimeter cubed, and this is wanting us to find the mass, and the volume is 40 liters. Now, if you look at the previous problem on number 3, we were solving for volume and we were in units of centimeters cubed. So how do I get 40 liters to centimeters cubed? Well, I gave you a conversion factor on your PowerPoint a bit ago, where I said 1 milliliter was equal to 1 centimeter cubed. Okay, so let's convert this. So we've got 1 liter is 1,000 milliliters, and 1 milliliter is 1 centimeter cubed. See how our liters will cancel and our milliliters will cancel? We'll be left with centimeters cubed. So take 40 times 1,000, and then you end up with 40,000 centimeters cubed. Okay, that's your new volume. So mass is equal to density times volume. So you've got density, which is 1 gram per centimeter cubed, times 40,000 centimeters cubed, which is 40,000 grams. And that's it. So if you were wondering how in the world it did that on the homework problem, that's how it does it. Whoops. Okay, now for number 5, let's see. We've got a cubic box contains 1,000 grams of water. What is the length of one side of the box in meters? I know that this one was a confusing one for some people. Okay, so first off, the mass that it gave was 1,000 grams. And again, we're talking about water, so 1. Okay, and this is wanting us to find the length of one side. Okay, so first off, let's find the volume. So volume is mass divided by density. So 1,000 grams divided by 1 gram per centimeter cubed, which is just 1,000 centimeters cubed. Okay. All right, now if we were to do the cube root of that, I know, that seems really weird. So if you do the cubed root of 1,000, that's going to give you 10. Why did I do the cubed root of that? Well, I did it because, well, first off, I probably should have waited to do that. I should have converted this to meters. Let me do that really quick. You still have to do the cubed root. So let's do 100 centimeters to 1 meter, 100 centimeters to 1 meter, and 100 centimeters to 1 meter. So see how this says to do it in meters? Okay, so if you take 1,000, take 1,000 divided by 100, divided by 100, divided by 100. Okay, now that gives me 0.001 meters cubed, but I need to know what it is for just one side of it. So in order to get this to just meters, I have to do the cubed root of it. Okay, so then that gives me 0.1 meters. So if you take 0.1 times 0.1 times 0.1, you get 0.001. So this is saying on this question, what is the length of only one side? You know, when you do length times width times height of a cube, this would be what one side of it would be. So the whole thing, if you do the volume of the whole thing, equals this 0.001, but it just wanted us to find the length of that one side. Okay, so that's sort of the review for chapter 1. We've already gone over everything that you need to know for chapter 2. We did all of the rest of this paper, and then we did the practice on that other one. So you should already have all of that. I'm not going to go through that again because we did that already in class. If you didn't get it, then you need to find someone that maybe did get it and see if you can copy their notes. if you have any specific questions over this, then you need to be thinking about them, or even some homework stuff, you need to be thinking about them for our class on Monday at 11, which I haven't decided yet if we're just going to do Zoom or in class and Zoom. I'm leaning more towards that we're going to just do Zoom during that time, okay? So, like I said, if you have any questions, you need to have those ready. All right, I will talk to you guys on Monday.